So, good afternoon, everyone. I'm Ruchira. As our organizing team gave me such a warm welcome, I would also like to welcome our audience for being here to hear my thoughts and opinion on the topic of expectations from space exploration. So, let's have an outline of what I'll be talking in today's presentation. First, we'll see that how the current space industry was once a future. Then we'll see how space exploration we expect a shift in missions, technologies, and tools. We'll also look forward to how fiction will be turning into our future. We'll see how new subjects will be incorporated in our syllabus in respect to the space sector. We'll see how job opportunities will be created. And last, we'll see our expectations from ISRO, and we'll sum it all up together in the last few slides. So before I start with the topic for today, I have some questions for my audience. The very first is, can you guys imagine your life without an influence of space? I guess most of us would answer no, because our generation has always been a part of space, because we already have heard a lot of things that happened in the past and a lot of things that are going to happen in the future in the space industry. So we can't actually imagine our life without the influence of space, right? Again, how do we think, or how do you all think that space exploration affects our daily life? If there are any answers, please read them out for me.
Weather forecast.
Weather forecast, yes.
Monitoring.
Right, okay.
Communication.
Right, very right. So if you sit, this will become another topic of discussion, right? So we can think of a number of ways that space exploration affects our daily life. If you simply search spin-offs from space exploration, you'll get a number of tech and tools that we use on daily basis that were first developed for space exploration. And my third and final question is, why do you all think that space exploration is important? Okay, so if there's no answer for this particular question, I guess when we all run through my slides and go through my presentation, you guys will have an idea about why space exploration is important and what all we are expecting from the future space exploration. So, as I said, the present today, that is the today's space sector, was once a future for someone. And that someone was Wernher von Braun. Now, who is he? He actually initially designed rockets for Germany during the World War II. Once the World War subsided, he then got an opportunity to move to the United States, where he became the leader of the American rockets team. And he then laid the foundation for launch of astronauts into the space and provided the boost necessary for sending men to moon. One of his quotes was, "I'm convinced that before the year 2000 is over, the first child will have ever be born on the moon." But I think that still is an expectation for space exploration, because we have not achieved that. But there were other things that he imagined and created that he thought would be possible for the future generations to achieve through space exploration. Here is the first image that he drew, which was of visualizing the mission control. It is a bank of computers which he thought would be needed to process the information from satellites. He believed that satellite data helped us to understand the Earth's environment, weather, climate, so on and so forth, which I think is very true. And if you closely observe, our entire world today revolves around satellites, its data, analyzing it, taking results out, and figuring out things on Earth. So one of his expectations, one of his imagination has today become our present. Another thing that he sketched out was anticipating the space shuttle. Now, if you observe closely, the vehicle he designed was kind of similar to the reusable space shuttle. The frontal portion was designed to hold the crew, that is the crew module, and the wings it had were supposed to be deployed when we are returning back into the Earth's atmosphere and landing, which is quite similar to the mechanism what the space shuttle used, right? So it already predicted that there would be such a vehicle which would help us to, which will be reusable and can be used for multiple missions and will land in the same manner as he predicted. So again, his imagination turned out to be the present that we had once lived in the past. The other thing that he imagined was future-bound three-stage vehicle. Three-stage launching vehicles are very common. We all see that multiple missions have been carried out using the three-stage vehicles. He had imagined this before the Apollo era. And then lastly is the lunar longing first trip to the moon. Now the concept was he sketched out an orbit-to-orbit spaceship which was around October 18, 1952. He designed it to transport people from a space station to moon and back. Now, if you compare this concept to the Artemis plan, where we have the lunar gateway, which is supposed to be a gateway between Earth and moon, where people can come from Earth, halt at the gateway, and then go back to the moon and come back. So the concept is quite similar. So he had imagined this somewhere in around 1952, and today we are going to live that thing in the coming 10 years. So the point I'm trying to point out here is, irrespective of what I say further in my presentation or in my slides, that one of the key takeaway that you all need to take today is that imagination, creativity, and the ability to implement your knowledge learned will turn our future expectations into our reality. Now, the second thing that we are expecting from the space exploration is shifts in our mission. Because we are all aware that in the past few decades, we have been revolving around moon, its exploration, understanding how moon came into existence, various hypotheses and theories. And we are all aware that the upcoming decades will be majority dedicated to Mars, right? But we somewhere need to move out of our comfort zone. The future space exploration should be more focused, I believe, on building the understanding of the outer solar system. The icy worlds out there have a potential of harboring life than the inner rocky planets. Earlier, we did have missions to the outer solar systems, which were mostly flyby missions like Voyager 1 and 2, Cassini, Galileo. But we never had a dedicated mission to study the ocean worlds, right? So the space exploration, we expect a shift in the mission targets, and the efforts, I believe, have already begun, because we already have two planned dedicated missions to the ocean world. First is the Europa Clipper. This is proposed by NASA, and it will search for signs of potential habitability on the Jupiter's icy moon Europa. The second is JUICE, which is an acronym, and the full form is JUICE, like Jupiter Icy Moons Explorer. It will explore Jupiter and its three icy moons, which are Ganymede, Callisto, and Europa. And this mission is proposed by ESA. Similarly, we are looking forward to a number of missions that will go beyond our solar system to the various asteroids and the Oort clouds as well, to understand how things function apart from our solar system, right? So that is one of the expectations from the future space exploration, that we shift our mission targets. We start moving out of a solar system and start exploring more to build a better understanding of how our own solar system originated and how our Earth originated. The second thing we expect is technologies and tools. For space exploration, we have a number of limitations on us. And these limitations are mostly because of the lack of technologies and tools. But we expect that the future space exploration will motivate us to break over this barrier. How? The process and the steps have already started. To give you an example and to think put it into motion, the images that were released by the James Webb telescope, they were the finest we had till date, right? And in one of the atmospheric spectrum of it, which was quite crystal clear, and it indicated the presence of water in it. So imagine with newer telescopes with higher capabilities like the next generation space telescope, which will have advanced capabilities of penetrating into the universe and giving us the data on how it was, like how it formed, what is past, how it is evolving, that is its present, and what will be its fate in the future. So we need more advanced tools and telescopes that will help us to penetrate into the astronomy side of space. Other than that, we have, technological tools, that is 3D printing, additive manufacturing. We all know it is very difficult to take everything, that is the raw materials from Earth, and then put it onto the spacecraft, deliver it, and then start building something on another body. Hence, we need to start developing technologies like 3D printing and prototyping which will be our future in the upcoming years. And we've already started the research towards it. If you simply Google 3D printing habitats, you can find a number of research articles and concepts that have been developed. We are using 3D printing in order to build habitats which will be the home for human colonies on Moon and Mars. Also, if you are aware, there is a 3D printer on International Space Station, which has proved to be a useful asset for all the astronaut crews that have been on board the International Space Station. Then to highlight is the multi-purpose tools, because expectation from space exploration is particularly for me is highlighting the working towards developing multi-purpose tools, because whatever we are going to take from Earth needs to be lightweight, compact and efficient. To give you an example of multi-purpose tools, let's imagine you are doing EVA, that is extravehicular activity on Moon, and you need a number of tools like hammers, compass, core tubes and drills and everything to carry to do the EVA. So you need a EVA toolkit. Now, instead of just carrying the toolkit, if we could combine it with an emergency stretcher, which can be used if there is an emergency, if one of the EVA member is injured, how are you going to carry that person back to the base or back to the habitat? You need something, right? So we can combine the toolkit set with a stretcher, and it can be a multi-purpose tool that can be used during the EVA. So we need to encourage more ideas which can, sort multiple purpose with minimum tools. So that should be an approach for the next future space exploration. Fiction turns into future. We all have seen sci-fi movies, right? And we all are fan of it. So we have seen topics like space tourism, bioengineered humans, biomining on Moon, Mars and asteroids, and interstellar travel. So my expectation from a future space exploration is that this fiction topics turn into a future reality. And I see the steps already been taken, because in terms of space tourism, we know that Blue Origin, Virgin Galactic have gained a lot of attention after their successful suborbital flights, with crew as common people, not people from the astronaut background, right? And now they have thousands of passengers on their waiting list. But the key loophole in this suborbital flight tourism is the cost. The cost for a particular ticket goes around $400,000. But if we keep exploring, and if we are trying to develop a future space explorable, humankind, then these things are going to change. Space tourism is going to be like very, very common thing. It is going to be something like going out, taking a stroll into a park and coming back. And there are various stages of space tourism. At the very first or the initial stage where we all are is the suborbital flights, which are nothing but completing one orbit around the Earth, giving them the tour of the Earth from the space and coming back. And then we'll have extended Earth orbit tourism, where it comes in the concept of hotels and resorts. And then is the extended vacations on Moon and Mars. So my expectation from the future space exploration is that one of the aspects is space tourism, that the local people who are unaware of how space is such a vital part of our lives would get a chance to see why with the help of space tourism. Second thing is bioengineered humans. Start bioengineering ourselves so that we are better suited for spending time in space, right? Because as of our current capacity to extensively explore space, it is basically hindered by our human limitations, because there are a number of challenges like radiation, microgravity, lack of air, temperature fluctuations, and we need to overcome all those in order to maintain a prolonged existence into deep space. So currently there is a research ongoing where scientists are working on discovering a number of genes in the human genome or other genomes that could help us regulate our health, design medical treatments and engineer organisms to survive the flight and the various challenges that we face while living in space. So if you are interested to know how future space exploration is going to be about bioengineered humans, you can go and check out the article or the twin story about Scott and Mark Kelly. Another aspect that we are expecting from space exploration is biomining. Mining of resources will therefore become a priority for extraterrestrial settlement. And the key role here will be played by microbes. How? I'll explain. So before I start talking about biomining, remember how gold once on Earth was this precious thing and people went nuts for it. And I hope everyone has watched KGF, so you have a clear idea of that. So jokes apart, similarly, as we explore space and learn more about the precious elements it holds, we'll ultimately start mining them, and there will be a huge market for it. But I can't imagine, building such heavy mining tools and then taking them to the asteroid or moon and Mars and then mining the resources and pulling it back to Earth. Whereas, like, we can use microbes for that purpose, which is very viable. And experimentation has been done on this particular area as well. So what happens is biomining is that we use certain kind of species of microbes or bacteria which feed or which eat rocks. Once they start decomposing this rock, they liberate, in the process of eating the rocks, they liberate minerals and precious gases like sulfur, nitrogen, and oxygen. So by using microbes, by implementing biomining, in the future space exploration, we can liberate precious minerals, gases, and change the global economy, right? Sounds interesting to me. And then finally is the interstellar travel. To be precise, we have actually achieved it, because the probes like Voyager 1 and Voyager 2 have already entered into the interstellar space. But in the future space exploration, we expect the change in the time taken to achieve the interstellar space, right? We are more focused on reducing the time that it takes to complete or do the interstellar travel. So the current research is going on the plasma thrusters, which are very inefficient if you try to use them here on Earth to launch something in space. But when you talk of launching something from deep space, it is quite efficient. So plasma thrusters could be a future for interstellar travel. Another approach for space exploration and reducing the time and increasing the interstellar travel could be the rocky planets. So what are rocky planets? Rocky planets are nothing but planets which are not actually moving around any particular star. They're just wandering into the infinite universe. So we can use them as a starship to achieve the interstellar travel. So the expectation is to lower the time taken and develop the tech and tools that will help us to reduce the time for interstellar travel and achieve it faster, so that we can have a greater pace of research. Because if you see the time scale of Voyager, how long it has taken to move into the interstellar space, the one or the team that worked on the actual Voyager no longer exists. So the other team has to start from scratch. So we are actually, I'll say, wasting our resources on doing the same task again and again due to the time gap. So the expectation from space exploration is that we develop tools and tech that will help us to reduce this time difference for interstellar travel. Now, as I mentioned earlier, we'll also talk about the new subjects that will be introduced. So far, we saw on a global level what all expectations we have from space exploration. Now let's come back to our student level thing, or someone who wants to pursue a career, what he should expect from the space exploration in the coming years. There are going to be numerous subjects that are going to be introduced, and I have named a few here. The very first is space architecture. Now, as we are thinking of Artemis program, of Gaganyaan, we are actually thinking in the direction of putting humans on Moon and Mars. And if you want to put human population on Moon and Mars, you need to provide them with an habitat or with a home. Just forget about the habitat, you also need to design a crew module. So designing a crew module and building habitats for human colony comes under space architecture. So this subject is going to boom in the coming next 10 years. And if you have even a slight bit of interest, go ahead, explore the subject. You might end up with a great opportunity in the coming 10 years. Then comes space medicine, which is we are quite aware of, because gravity, that is microgravity, has a number of destructive effects on our immune and physical abilities. So we need a number of research going on in this particular space medicine subject, so that when we have full-fledged activities going on, sending humans to Moon, Mars, and coming back, we have the expertise that is needed in order to counterback the microgravity effects on our body. So space medicine is also going to be a very new subject that is going to acquire a lot of market, especially for students in the coming 10 to 15 years. Then comes geology and astrobiology. Now, if you talk about exoplanet or studying exoplanets, you cannot skip geology or astrobiology. Or even to give you an idea of whatever exploration we are doing on Mars till date is just based on geology and astrobiology. So both these subjects go hand in hand, right? Geology helps us to study the rock, which tells us about the past, present, and future. And astrobiology tells us if there was ever a chance of life existing on that planet. If yes, what were the conditions? If not, why not? So if we are thinking in a broad spectrum of exoplanet things, we need geology and astrobiology, as well as we need to build an understanding of how life originated here back on Earth. So doing comparative analysis between the exoplanets, the outer planets in a solar system, and Earth, we are going to get a huge data that we need to analyze. So we need a number of experts who will be working in the field of exoplanet geology or astrobiology, psychology, and physiology. Living in space in prolonged mission, you're confined to smaller spaces, that is the crew module itself. And you have to work with a limited number of people, that is 4 to 5 crewmates of yours. And you have no privacy. So that somehow creates an impact on your psychology. And that affects the entire mission. Because if the crew is fine, the mission is fine. If something happens to the crew, we cannot help but abort the mission. So in both the aspects, in terms of physiology as well, if you're not functioning like physically, you won't be able to do the daily tasks that have been assigned to you as a crew, right? That is going to hinder your mission. So we again need experts who have, knowledge and how to overcome the barriers that we'll be facing once we start actually sending colonies to Moon and Mars, so that we can cope up with the obstacles that will be particularly created by space psychology or space physiology. Then to end with, the another two subjects that will become like as common as we take science, physics, maths, or engineering are going to be space food and innovation and law and policy. Space food, if you observe the history of space food, it has been developed in a very short period of time. If you see the drastic change from the Apollo food that was provided to the food that has been provided today, you will see that within a short span, they have done a phenomenal work. But again, if the number of crew there was limited. But when we talk of sending people, like huge colonies of 100 to 200 people on Moon and Mars, you can think of the necessities of food, water, right? So we need a lot of research and innovation on how to use the in situ resources on particular planet or moon in order to generate our food, or also how to send food from Earth to that particular targeted object in the universe. So we need a lot of innovation in terms of space food. Then comes law and policy. Just to give you an example, we are here on Earth, limited people here, and still we have so many conflicts. Just think of the scenario when you have multiple colonies living on multiple bodies in the universe. You need to have some certain base foundation laws and policies that everyone needs to follow in order to maintain global peace. Global as in just not on Earth, on every body that will be setting colonies on. So we need a lot of expertise in terms of law and policy who will develop the minimum criteria that the colonies would have to follow and the people on Earth would have to follow in order to maintain the space exploration without any, human hindrance. So the subjects like space architecture, psychology, physiology, geology, astrobiology, food, law, and policy are going to be as common as science, maths, engineering. So I encourage people, if you have even slightest of interest in these subjects, just go, explore, and maybe you can find something that you can take up as your career in the upcoming 10 years. Because you will also understand in the coming next 10 years, ISRO is also going to boom a lot. So maybe you can help in the research of Human Spaceflight Center as well. So if you are interested in these subjects, go and pursue them. That's my message from this few slides. Now, as I discussed the various change in the subject due to the space exploration, there'll be change in the jobs as well. Space jobs of the future, due to the increased space exploration, there will be new opportunities for employment. We'll have food engineers, mining specialists, media specialists to keep a data of all the things that's happening, to keep every colony aware of what's happening on the other colonies or on Earth back. So we need media specialists as well. Then additive manufacturing, holoportation specialists. If you have watched Star Trek, you could have, if you remember, they could send or teleport or holoport someone within a blink of time, right? So we need that tech and those specialists as well. We need space tourism managers, because once space tourism starts, we'll need people similar to how we have guides when we visit Taj Mahal or any monument here on earth, we have guides who tell us the entire history, how things happened, what was the background, who did it, why he did, and so on and so forth. So we'll be needing managers or tourist guides for space tourism. Then space architects and construction experts, because every time we cannot send raw material from Earth. So we need space architects and construction experts who can utilize the in situ resources on that particular body in order to build the habitats for the human colony. Then come space medicine experts and space traffic managers. I would like to highlight space traffic managers because the pace at which we are sending satellites or spacecraft into the lower orbit and beyond is crazy. Because if you are aware of the air traffic management, similarly in the next 10 years, we are going to need space traffic management. When we'll have to keep track of every object that we are sending in, the path that is going to follow in order to avoid collisions, in order to avoid space debris, and the future hindrance that it will cause in the upcoming missions. If you're aware, there have been collisions between the satellites that were sent due to lack of their data that was being sent to the respective owner of that satellite. So we need space traffic managers which will help up to cope up with this problem. So there's going to be a huge rise in job opportunities and employment due to the space exploration. Now we saw globally, we saw in terms of students aspect. Now let's come back as an Indian student, as India whole. So what are we expecting from ISRO, from the future space exploration? What's in for us? So we all know that the country's first space station is likely to come by 2030 by the Gaganyaan mission. So Gaganyaan mission, according to me, is going to be the game-changing card for ISRO. The mission includes 3 flights, out of which 2 are unmanned and 1 is manned. So what is the significance? Why is it going to be a game-changing card for ISRO? First, it will enhance and help science and technology, as it will involve creation of new labs, various disciplines or the subjects that I mentioned, the various industries and departments. And secondly, it will help in the industrial growth, that is privatization. You're all aware there are a number of startups, privately funded startups that are coming up in India. And with the organizations like InSpace, the face is going to change forever. So, if you see till date, ISRO has been restricted due to the funding and overall politics in terms of space exploration. But due to the private funds flowing in and ISRO shifting its focus from just exploring the planets to human exploration, it's going to be a huge deal. And we expect India to do more in terms of human exploration, and we have a number of other missions which are also coming up, like the Shukriyaan, which is going to be focused on Venus, then the El Aditya Solar, which is going to be the first expedition of ISRO around Sun, and then Chandrayaan 3, which is a revisit back to Moon. Another key aspect that will change our expectations for future space exploration from ISRO itself is the Human Space Flight Center, which was recently inaugurated, and it will be responsible for implementation of Gaganyaan project, which involves end-to-end mission planning, development of engineering systems for crew survival in space, crew selection and training, and also pursue activities for sustained human space flight missions. So I wanted to highlight that due to the start of Gaganyaan mission in the coming 10 years and the inauguration of the Human Space Flight Center, my personal expectation from ISRO is that the dream of every Indian student to become an astronaut or a leading professional in a space sector will come true without bearing any hindrance like not getting admission in particular university outside or not having enough funds to pursue or so on and so forth. That obstacles will now subside and we'll have full-fledged opportunities for Indian students to explore and take up space as career. So boom of space age in India and the next coming decades are about space exploration. And I would definitely like to highlight that 8 out of 10 students are going to choose a field that is directly or indirectly related to space sector. Now to sum it all up, we can combine all our expectations from future space exploration into 4 key points. First is innovation. Second is culture and inspiration. Third is new means to address global challenges. And fourth is the expanded economic growth. Let's have a look at each one of them. Innovation. Ambitious space exploration are driven by the need to enable reliable and safe operation of crew and machinery. So we need innovation in terms of new transport capabilities, development of highly reliable human and robotic interactions. We need autonomous operations with limited communication and logistic supply that will be needed from Earth. We need miniaturization of components and develop new in situ capabilities. Miniaturization, because if you see, there has been a shift of big to small in terms of satellites and spacecrafts. If you observe the very first satellite that was launched, apart from Sputnik, you'll see that they were huge structures. But the satellites that we are launching now have the same performance capabilities, but their size have reduced drastically. So we need this switch from big to small, that is miniaturization. So one of the expectation is innovation in healthcare, medical diagnostics, and therapy tools, which will be must once we are doing human space exploration. Second point is culture and inspiration. Inspiration because exploring Mars, Moon, asteroids itself is an inspiration for humankind. We are uncovering new knowledge about solar system, its past, present, and it also providing us and helping us to understand more about our own Earth. And also we are deepening and shedding a light on the possibility of past, present of life somewhere else in the solar system. How about culture? Culture because while we are working on a particular space mission, we have a number of people who have diverse backgrounds, not just in terms of technical aspects, but in their personal life as well, who bring a lot of valid opinions, knowledge to the table. So the exchange of culture also helps us to somehow build that rapport between the crew, which ultimately helps to strengthen the mission. So one of the expectation from the future space exploration is that we enhance our culture and we stay inspired in order to explore more. The third is the new means to address global challenges. In the next 10 years will be essential for building international partnerships for exploration and also addressing and highlighting the sustainable space exploration. Sustainability is the key to our future existence, is that what I believe. Also, we need to start planning new laws and policies to protect the planet and the services that are based on the space-based assets. Also, space exploration will create opportunities for enhanced international coordination and cooperation on topics such as space debris management, space weather monitoring, and also setting up colonies on various bodies in the universe. And also, there is this concern, if you find something which is valuable on another planet or another asteroid, will you claim it as your own, or will you make the entire world aware of it, and then you will decide some laws or ground boundaries that we need to follow in order to harness the resource? So we need to think a lot in terms of global coordination and cooperation when we are thinking of future space exploration. The last is expanding economic growth. Developing reliable space exploration systems, incorporating human decision making, troubleshooting, flexibility are possibilities of enhancing economic development. Publicly funded space exploration has lowered and will lower the risk and the costs that are involved in working in space. So the space industry will be turning into a multi-billion-dollar industry in the coming 10 years, and it will be a huge one because it will be a never-dying industry. We'll always keep exploring space. We'll always keep generating opportunities for employment, for bringing in new people for their improvement, development, or even building their careers itself. So to conclude, I would like to say that these all were my personal expectations from space exploration, because the topic itself is so wide. You can yourself come up with a number of topics that I have not covered in this particular presentation. So now I would like to stop and would like to hear your views and would like to take questions if there are any.
That was actually great. Actually, it introduced many fields and opportunity in space that we actually don't know till now. That means space field doesn't limit with rocket science. It has many more aspects. The space is open for everyone, right?
That is very true. That is very true.
That was great. So now, if anyone has any questions, you can raise your hand. And meanwhile, we actually got some questions to discuss with you. So as you already mentioned about space tourism, today morning there was a news in that Japan announces mega space migration program by recreating Earth's gravity on Moon and Mars. That is, as we saw in science fiction movies earlier, they're actually creating a conical living structure with artificial gravity, complete public transportation, green areas, water bodies, and everything just like as an Earth. So it is actually happening. What is your views on it?
As I mentioned in one of my slides, I believe that is the third stage, the extended Earth orbital flight stage, where we have resorts or similar structures which are, I would say, replicating Earth somehow, creating an environment similar to Earth so that people have comfort. Personally, yes, excited, of course. Who doesn't want to have that opportunity, or who doesn't want to have that experience? But talking about, like, it is just an announcement. They've not yet achieved it. And it's going to be a huge time period till we reach that particular, step. But I'm happy that they've announced it, and I hope that we achieve it. But again, it is not something that can be done just you said it today and you'll be done by tomorrow, right? You need a lot of research, you need a lot of people working on that particular concept, and it has to be a trial and error process. They'll do it multiple times, they'll fail, then again do it multiple times, and then as it is Japan, they'll somehow achieve it. So yes, I'm happy and I hope they achieve it, and we all get an experience to be there and see how it is going to be.
In continuation to the question you said about the stages, there are stages for the integration of more technology into existing space, and but how can we bring these things into the field in the first thing? Like you said that there are pharmaceuticals need which can be fulfilled in a space and space architecture, but we can do those things when we have a trace in a space, like at least we have somewhat a footmark on a space, like a space station or a method to go into space. That's where the problem starts of not getting enough hands-on information and materials. What should we do about that?
So I take this question as you are aware of the possibilities of various fields, but you are not sure how to implement them. Am I right?
Yes, ma'am.
So yes, that is true. We all lack the knowledge of how to implement. But the other part is that every time you have an idea that is related to space, it is not necessary that you get a chance to go in space, see how things are there, and then start working on the idea. That's not the necessity. There have been a multiple research, as I said, in let's take space architecture. So it's not necessary that you go on Mars, see the conditions on how Mars are, on Mars how they are, what material we can use to build. No, it's not done that way. We try to manipulate and interpret things, right? We use simulation softwares. So I understand your topic that how should I start when I don't know where to start? So what you can do is, if you are interested, say, in space architecture or space medicine, first try to get into the community of that particular subject. Then try to connect with someone who is already working on some kind of research that is going to be useful in the coming 10 years. Need not to be doing you need not to be included in the research, but just keep a tabs on it. Keep an eye what's going on, how things are processing. Once you get the knack of it, you'll try to understand that how you develop a research idea or how you develop technologies for space. Everything doesn't need to be first you go there, see how things are, and then come back and do research. That's not the thing. It was not in case of Apollo as well. If you see the geological tools that they have used during the Apollo and the geological tools that they're going to use for Artemis, it's a huge difference. How they first interpreted, they took the tools according to their knowledge and research that they had on Earth. Then they tested it on Moon. They got some drawbacks, and now they have started improving. Similarly, you can develop a space habitat. Let's take example of space architecture. Try to present it in conferences or smaller events like Space Habitat event by Habitat Mate. There you'll meet judges and panels who will give you an idea about this might not be the right thing. You could approach this way. Once you clear those certain stages, maybe you'll get a chance to develop an inflatable habitat which could be tested on the analog sites here on Earth, which are quite similar to Mars and Moon, where you can interpret that how things would go wrong on Mars and Moon, and then you can note those things down, again redo your work, come up with the solutions for those problems, and then finally it can be then sent to Mars or Moon for actually being used. So it's a long process, I understand, but try to get in the community, try to read their ongoing research, also start working on your own small ideas, try to talk to people and try to present it. No matter if it is wrong, let it be wrong. If it's right, let it be right. Don't be very excited that I got it right in the very first place. Don't do that. Just try exposing yourself to harder situations and you'll get the knack of it. I hope that answered your question, or I just deviated. I don't know. If not, please let me know.
No, ma'am. Thank you for that.
Hi, Ruchira. Hi, everybody. Hi, thank you, Ruchira. So I'm Milava here, and I have a few questions that are in sync with what we came across when we spoke with Prasad Doke, Shreya Sandara, and then Sahit Reddy, right? So my first question would be, is that as you have expectations for space exploration, do we also have some obstacles or problems that we very clearly see and are developing some solutions for them? Could be based on finance, could be based on collaboration. I just wanted to know if there are some specific hurdles that you have identified and are working towards solving them.
Of course, there are a number of hurdles because you're talking of space industry. It's not the one that is you can just go into space industry, build your career and you'll be like famous one day. No, you'll always face obstacle in space industry. So as I said, these are all our futures expectations from space exploration. They are not our immediate expectations. And there are going to be a lot of problems. As I said, funding, first of all. If you look back to ISRO's history itself, due to lack of funding, due to just lack of funding and political barriers, we couldn't achieve things that we could have already achieved in the past 10 years. That is what I personally believe. So funding is one very first thing. But now we see things changing because of the organizations like InSpace that was inaugurated very recently and private funds flowing in. So things are changing, but it is going to take a lot of time. We need more people to start their own ventures with funding so that we have a number of people working towards small segments of a particular vision so that we can all collaboratively achieve it. Because individually working towards one particular thing will take you a huge time compared to small segments working on the same vision. That is what I believe. So first thing is funding. I believe there should be no political barriers henceforth on Indian space exploration, but I don't see that window opening very soon. But that is going to be again an hindrance. Third thing, as you said, collaboration and global partnerships. Of course, they are always needed because sometimes you don't have the resources that they have. Sometimes they don't have the technology that you have. So you have to work mutually in collaboration with things. So, of course, we need international collaborations. But again, what I believe is we need coordination and collaboration within India, within our industry itself. Because what I've observed is people, instead of talking things out, discussing with each other on how we could collaborate and make things possible, they are more into the competitive mode. They are not onto the mode of actually coming together and working towards something. So I feel bad personally on that aspect, that I feel that within the country, we should all, of course, there are competitors. You keep your information to yourself. But again, there is one way where you come together and collaboratively work on something. If you see, this is what I've observed, every individual company in India is working kind of on the same topic. But we have a number of companies. Instead of that, we could have collaboratively come together, used our very good resources at one place and could have very quickly achieved what we have achieved in the past years. So yes, collaboration and coordination is one of the things. And I also believe the major problem here is the lack of awareness of opportunities between young generation like you and me and the mindset of the older generation. Because even you here people present are studying aerospace engineering. I study aerospace engineering, but we know this much of what is there in the entire aerospace engineering. So somewhere that needs to change, and don't blame anyone else. I'll say blame yourself. You have resources. Yeah. Go on Google, type keywords. You'll get everything you want. just keep surfing instead of watching series and movies. Do watch them.
Right.
Nothing against that. But spend some time here itself, because I've been doing that and it helped me a lot in the last 2 years, especially during the COVID. I just started typing in keywords, getting an opportunity, talking with people, networking. It helps a lot. That gap between knowledge about what exists and what we want to do, that you need to cut short. So start exploring, typing in keywords and looking for opportunities. And second thing is lack of the mindset, as I said, in the older generation, because sometimes you might come up with a hypothetical concept, right, to develop a project on, which might be still in the space sector, but it is not practical. It is not engineered stuff. So sometimes it might happen that you won't get the support that you need to develop that particular concept. It does happen with students when we are doing projects and stuff. So don't dishearten yourself. Keep it as a side project. Start to work with people who have similar mindset and slowly develop that project. Don't give up on that just because there is lag between the mindset. So believe that you could, because sometimes it does happen that, for example, I want to work on Matryoshka brain. Now, for some people, they've not even heard of the word Matryoshka, and they'll tell me why you're working on this project. What will you achieve, right? I have my personal goals that I want to achieve through that project that he might not be able to comprehend. So keep it as a side project, do something technical, but also keep that project in your hand. Keep working on it. Might be someday that hypothetical project might turn out to be a solution to some existing problem that we may have not encountered yet. So yes, to sum up, like the problems are funding, lack of collaboration within our nation and obviously outside, political barriers, lack of awareness between the students who are pursuing careers in space industry, and third, the gap between the mindset. That's what I believe.
Right. So I think if I could add something to that, like communities like SEDS, AstroCapsule, SGAC have their work cut out for them to change the existing mindset and to the new generation and bringing them opportunities together. I just have one more question. Being the only bioengineering student in this meeting, I actually wanted to know more about, just a little more, not too much, about what sort of direction would I be looking at if I wanted to pursue my professional career into astrobiology or bioengineered medicines? Some tips on that.
I'm not even an expert on any field, but that field is like very far away from my expertise. But I do have some friends from bioengineering, and I'll do connect you with them.
Definitely.
But to answer your question, you can go into the topic of extremophiles, maybe, if you are interested in. You can explore a lot, because we have just studied about radiation. D-radiodurans helps us somehow to deal with the radiation problem. But apart from D-radiodurans, there is a number of extremophiles that could help you tackle number of problems that exist in space. As I mentioned one here, that is biomining. Instead of taking so heavy machinery and tools to mine resources on asteroids and moons, you could simply develop a system that could help, speed up the process of biomining by using microbes, rock-eating bacteria. So you could work on that particular aspect. Apart from that, in terms of finding life, biosignatures and stuff, you can again go on that area. I'm not really equipped on how you can do that, but I think there was this recent study on how I think electric signal transfer in bacteria could be used as a impulse for something. I don't remember the research, but there was something that was related to space and a microbe again. So you can check out that different direction itself. And there are a lot of opportunities for, as I mentioned, bioengineered humans. That is going to be the future, and that is going to be the future because we are limited with our human capabilities. So you can work on that area as well. And I'll definitely connect you with those people who are working.
Thank you so much. Means a lot. I'm done.
No problem.
Thank you so much, Ruchira.
Thank you, Archana. Hello, Ruchira ma'am. I'm Shansi.
Hi.
Yeah, I want to ask, what are the major mission you want to happen in the coming future that may open a new door to deep space, and what are the constraints in it?
Missions that I want to happen. Quite a tough question because I want all the missions to happen because they're going to open a lot of opportunities for research and technological stuff and so on and so forth. But as I mentioned in my slides, I want missions particularly directed towards the icy moons, because if you read the literature, and it's really fascinating because they could really be, the thing that we are looking for, creating a human colony somewhere. They have that habitability condition. So I'm more excited about the missions that are planned for the outer space icy ocean worlds, and also I'm excited for the Psyche mission itself, because if you read the story of Psyche mission, it is fascinating. They believe that the asteroid was a core of a planet before. It is not actually an asteroid, but a core of a planet. So just imagine if we could find a remnant of a planet that was being formed. I'll simply compare this to a fossilized planet. What do fossils do? They help us to trace every history of that existing organism or anything that was there. So maybe if it is a core of a planet that was not formed, it will open every possible aspect to understand how our Earth was formed, how life originated on Earth, and how there could be possibilities of other theories like life being originating from silicon maybe instead of carbon. How could that be possible? Because maybe the core has another element than the core that we have on Earth. So I'm specifically interested in that mission as well. So for now, I guess those two I would like to answer. Yeah, thank you.
Yeah, so firstly, it was a very great session, ma'am. And I wanted to ask that, as you've already said about the upcoming Indian space station that will be launched by 2030, and even previously ISRO has had many successful missions and launches, and now they are eyeing on launching the next Mars mission in 2024. So what are your views on that? What do you expect from the next Mars mission for India?
Thank you for the question. Give me a second to think about it. So, yeah, I mean, in terms of ISRO, we have not actually done core research about any moon or planet. If you see the mission so far, even if we count Chandrayaan, it was a failed attempt, so we couldn't actually send a rover or a lander to do actual experimentation on moon itself. So we've not achieved that capability of actually being there technologically on the surface of the planet or the moon and performing experimentation. So my very first expectation from any mission that ISRO does in terms of moon or Mars is that we are able to achieve that stage where we land at least a rover or a lander which is able to do basic experimentation in terms of astrobiology or geology. That is my very basic minimum requirement that I expect that we'll be able to achieve through ISRO. Apart from that, it's open door. You can expect anything to happen. You can test another technologies that you are looking for. Maybe you can send your the human robot developed by ISRO. Maybe he can perform some geological field work there by using the tools. We program the command, she'll do the stuff and give us the data back. So it's a number of possibilities. But the very bare minimum that I expect from any mission that we are doing in terms of planets or moons is that we at least put something on the surface, either a lander or a rover, and do the basic experimentation. Because that will be a huge milestone. Once we have that in our hand, we can start exploring further. That's what I believe. I hope that answers.
Yeah, it is. Thank you so much.
I have one more question. That is, from childhood, we are always fascinated about life on other planets. We are always about it. So, very recently, astronomers at MIT have detected a strange radio signal that is similar like a heartbeat, appear to be flashing with surprise regularity. So, what is your thought about on this topic, life on other planets?
it is a false alarm, according to me, because earlier also there have been such signals which were detected, but we did not have any follow-up with those signals, neither from their side, if they exist, or from our side. So I don't actually believe that we have the capability to encounter an civilization that is a type 2 or a type 3 civilization, if you know, on the Kardashian scale. So what I believe in terms of life on another planet is microbial, of course, because take us for instance, it's been billion years that Earth has been formed, and we still, if you look at the evolution of Earth, this is my hand, if you can see, this is the evolution of Earth. Till here, it is all microbial, and we are just somewhere here that is human. So if there ever exists a life on like another planet or a moon, it is going to be in the microbial form. Because if you compare what I have shown you, the entire evolution in terms of life of Earth, entire thing is microbial. We are somewhere this part of it. So I believe that if there will be in terms of microbes, and not necessarily the microbes that we know. Not necessarily based on carbon, not necessarily based on silicon. It can be based on phosphorus as well. Because we never know what were the founding conditions of the planet when it was actually going through the process of life formation. And of course, I'll be excited to know that there exists a life other than ours, because then again, that will help us cope with our ego that we are not the only intellectual species. They might develop an intellectual species on that particular planet as well. So if there's life ever, it's going to be in the microbial form.
Thank you. That was interesting. I guess there is no more questions. Talk was very clear and precise, and I hope everyone has enjoyed it. And we are hearing it from a very enthusiastic student, so it is very interesting. So also it is beneficial for every department students, not only aerospace. It opened a new door for everyone. So thank you.
Yes, that's what I want to. That's what I want to highlight. No matter which background you are, the jobs I highlighted and the subjects that I specifically included in my presentation are an open door for everyone. So just go and explore. You never know where you find yourself in the 10 years. So if you are interested in space, if you are a space enthusiast, explore every possible way you can. Maybe you'll find that that's not my interest and I didn't want to pursue it any further. That's fine. If you find that this is what I was looking for, you'll be happy and you'll be doing what you want to do for the next 10 years. So you have both the possibilities. So just go, explore, and keep doing things that you love about space. That's what I would like to say. And once again, thank you, SEDS Nebula chapter, for inviting me for this particular topic, which was very exciting. I was very concerned that what should I include, because it's a huge topic of expectations. But I hope I could deliver all that I could from my side. And I hope you all enjoyed. Thank you once again for inviting me.
We loved it. Thank you so much for it. Thank you.
And all the best for your future.
Thank you so much. All the best to you guys as well. Bye.
Bye, everybody.